Eric Burgess here, and we have been told the following. If one card is drawn from a deck, find the probability of getting these results. So it has to do with cards, and I know some of you guys have never really played with cards before or know them very well, so I highly recommend having a deck in front of you, like printed out on a sheet of paper, or having a physical deck so that you can just follow along and familiarize yourself with the cards. So let's do our first one here. So they want to know the probability that we get a king. And so remember, probabilities are always of the form of the sample space on the bottom. Sample space. That's all our possible outcomes. And then on the top is the condition. Condition. And so our condition here is the card is a king. And the sample space is all the cards. So we just need to find out, how many kings are there. And we know there's 4 kings, and we know there are 52 cards. So it's 4 over 52, and this actually reduces to 1 over 13. And again, if you want, you could type this into a calculator. You could type a fraction by hitting the green key and then F1 and just selecting the first option. And you could type 4 over 52 and you'll get 1 over 13. If you aren't that comfortable with the division, you can just do that. All right, so that's our first one. Pretty easy. You could turn it into a decimal too, or a percent. Those are all going to be expressions of the probability. So our second one here is a spade. And so following our first example, it's a condition over a sample space. So it's still, our sample space hasn't changed. It's still 52 on the bottom. And now we just ask, well, how many spades are there? Well, there's 13 of every kind of suite in the deck. So there's 13 hearts, 13 diamonds, 13 spades, and 13 clubs. And so the top number is going to be 13. And this is going to reduce to 1/4. And again, if you don't feel comfortable with that, we could just type it as a fraction. And you could just do this. Some teachers don't even require you to reduce. You could just write it as is, and that could be your answer. But you could see we can verify that it's 1/4, just so we're extra 100% sure. And that is our answer for number 2. For number 3, it's a jack of clubs. So we say, okay, jack of clubs, that's 2 conditions. So there are 13 of every suite. That's the diamonds, clubs, spades, and I'm forgetting one, hearts. But there are 4 of every card. So for example, there's 4 2s, there's 4 3s, there's 4 jacks, there's 4 queens, there's 4 aces. So here they want a jack of clubs. So it needs to be, our top condition would be a jack and a club at the same time. It has to fulfill both of these because it's the jack of clubs over all the cards. Our sample space is the same. Well, okay, there is only one card that is both a jack and a club because there's a jack of each kind of suite. So there's a jack of clubs, a jack of hearts, a jack of spades, and a jack of, I can't remember the last one, diamonds. There's a jack of diamonds. So in this case, we've already said that it's the jack of clubs specifically. So there's only one jack that fulfills that. And then there are 52 cards. And so that's just that. That doesn't reduce to anything. There you go. And then finally, we have for 4, we've got a 6 or a 3. So we say a 6 or a 3. And on our bottom, our sample space is still all cards. So that's just going to be 52. Now our top is a 6 or a 3. So or means plus, and we know that there are no 6s that are also 3s. So we're not going to have any cards that overlap with each other. And you might be wondering, well, of course that's true. Well, in number 5, it's not going to be true anymore. So it's important to notice that there's no overlapping cards that are both 6 and 3. So we say, okay, well, there's 4 6s. So that's 4 cards for the 6. And then there are 4 3s as well. So we would add another 4 cards for the 4 3s. And so this is going to be 8 over 52. And you can write it like this, or you can use the calculator to reduce. Whatever makes you feel more comfortable, the 8 over 52. Or you could just divide out by hand and do the actual division by 4. And we get 2 over 13. Cool, cool, cool. And now our last one, number 5, is a 3 or a heart. And so say, a 3 or a heart. So our bottom number is still 52, just like it was before. But 3s and hearts. Okay, so we know there are 4 cards that are 3s. So we put a 4 down. And we know, well, the or means to add, that there are 13 cards that are hearts. But there is one card that is the 3 of hearts, meaning it is a 3 and it's a heart. So we counted that particular card in this one because it's a 3. So that was in our 4 3s. And we counted it in this one because it's also a heart. So we counted that card twice. So we cannot do that. And so we need to take it off one time. That way we only count it once. And if you remember, the probability formula for or is the probability of A or B. That's equal to the probability of A plus the probability of B minus the probability of A and B. Right, so if our events are exclusive, like they were in part 4, then we only use this part, and this part doesn't come up, which is why I said, oh, look, there's no cards that are both 3 and 6. But when the events overlap, they are not mutually exclusive. There's a bit that gets counted twice, like we just saw. And so we have to subtract it off in order to count it only one time. And so we're going to get this. Now, this is just going to be 13 minus 1 is 12, and 12 plus 4 is 16 over 52. And you could write that, or check this out. You could also write it like this. You could come into your calculator and type a fraction. And instead of writing this, you could actually just write the whole expression. 4 plus 13 minus 1 minus, 4 plus 13 minus 1 over 52, and it will reduce for free. And we get 4 over 13. And that is our answer for the 5th part. If you're a Citrus College student, definitely feel free to stop by online tutoring. We're there to help you. Subscribe, and we'll catch you in the next problem.